Hello and welcome to this sonnenAcademy accreditation training video. So we're going to have a look now at the main connections of the sonnenBatterie system as well as the metering and CT setup. So first thing, the hybrid 9.53 has the ability to take PV directly into it. So we're just going to very quickly have a look at the connections. I'm not going to show you how to do the entire PV installation, so we're just going to take it directly from the associated DC isolator. Although the hybrid system does have a DC isolator at the top, it's purely there for testing purposes. It's not an applicable isolator under the eyes of the standards. The hybrid system comes with two sets of the SunClicks connectors, so again very straightforward to connect them to the DC. I'm not going to show you how to do that because it's pretty self-explanatory. You don't need any kind of tool or anything, and you've got the dual MPPTs. So if you don't use both MPPTs, the system does come with blanking plugs, so you can blank those off. The AC connections for the sonnenBatterie system, although the Sonnen system does have a plug, most inspectors nowadays do ask for an associated AC form of isolation. So this connector here is actually an applicable form of isolation under the eyes of AS3000. However, just to keep everything consistent with the rest of the industry, it is probably a good idea to put in an adjacent AC isolator. Obviously, if you're within 3 meters of the main switchboard, you don't need to worry about it. So what I'm just simply showing here is not trying to teach anyone how to suck eggs, but just how to wire the AC isolator for the purpose of simplicity. So AC just coming straight in, obviously tighten the gland, and you bring the other side of the AC in, running it back to the switchboard. Now, as you'll see in this installation, the switchboard is well within 3 meters, so technically didn't need to do this. But again, just wanted to show almost, I suppose, the worst case scenario. If you did need to wire an AC isolator, that's the process, and then the wiring back to the main switchboard. Now, with all of the sonnenBatterie connections, it is very clearly stated in the installation manual the maximum run of all cables. So these have been taken into consideration, all the parameters such as voltage drop. Voltage drop being one of the most, I suppose, important features of the sonnenBatterie system, that it will limit output. It will limit output of any DER, any renewable energy system, so you obviously need to take this into consideration. So here we go, AC isolator happily alongside the DC isolator, and then we bring the AC into the switchboard. So before we get into the details of that setup, we'll just have a quick look at the 3-phase configuration. So as you can see, the top of the 3-phase system, the 8.03, a lot less connections. It doesn't have a PV input, so the only real connection you need to worry about other than Modbus and internet is the AC itself. So again, just as with the hybrid 9.53, if you're, or with any system, if you're within 3 meters of the switchboard, you don't need to worry about isolation. Also, the isolator, or the connection here, as you can see I'm just connecting right now, is technically an eligible form of isolation, but to keep, I suppose, most of the electrical inspectors happy, we do advise that you stick on an adjacent form of AC isolation. Now, obviously, given this is a 3-phase system, a little bit more wiring to do, given that we've got all 3 phases to have to consider. Now, as these Sonnen systems, I suppose, cater for all different situations, we can't be specific on isolation requirements and cable run requirements and everything else, so we don't supply the isolators for the Sonnen systems, but the recommendation here is that an isolator, probably up to about 20 amps, is sufficient. The 8.03 has a charge discharge capability of 3.3 kilowatts, so 1.1 per phase. Now, this obviously needs to be latched isolator to be able to break all of the poles simultaneously. Now, it's always a slight tricky context really to look at an isolator and decide whether you take the supply in at the top or in at the bottom, because let's say you would always take a supply in at the top, out through the bottom, that's fine if the sonnen system is discharging, because then the load is on the output side, which is at the bottom of the isolator. If however the sonnen system is charging, it's the other way around. So without having to have some ridiculous configuration, normally wire the isolator on the understanding, on the basis of the sonnen system discharging, because it tends to make more sense. So there we have three-phase latched isolator for the AC, and then just like with the hybrid, we then take the AC cable into the switchboard. So before we go on to any of the metering and CTs, let's have a quick look at the Ethernet connection. So what I'm illustrating here is both the Ethernet and the Modbus connections. Ethernet being the grey one, Modbus being the pink, the C-bus cable, because the C-bus cable obviously is terminating within the switchboard. Both need to be rated to the voltage within the switchboard because they're passing through it. The labels at the top of the sonnenBatterie system very clearly labelled so that you know which is which. So first thing first, Ethernet connection. For simplicity's sake here, I've just passed the cable straight through, and I'm going to show this being terminated through very simple Ethernet over power. So these broadcast the Ethernet through the AC of the property, so that just literally plugs straight into the modem, and then from here the internet connection is then broadcast, which the sonnen system picks up on, so we don't need to worry about running cable all the way back through. So this is the first, probably the simplest of the AC connections for the hybrid 9.53. Okay, so AC is in. We've just wired the MCB there for the power going to the meter itself, and just tapping that end to the bottom of the main incoming supply from the grid. So as you can see, the switchboard here has been pre-wired. AC comes in, main isolator, then off to all the load circuits, and the PV is part of the load circuitry. So the PV could even be on a subboard. So now we're just wiring up very quickly the wiring for the actual meter itself. So active neutral. And then here we're going to bring the meter in. So these come as part of the accessory kit. And it already comes with a section of the Modbus cable pre-wired into it, and a connector to be able to reconnect the Modbus to the supply, which we run back to the sonnen system. Now that little jumper tells us that this meter has already been pre-wired and pre-programmed to be able to allow for the grid consumption. Previous sonnen systems you had to pre-program them, but these ones you had to program them, but this one's already been pre-programmed. So active goes in, and then neutral goes in. Okay, and as you can see here on the single phase systems, it's very clearly labelled where neutral and active need to go. So here we're now going to bring in the CT sets. Now all of the sonnen systems come with the same amount of CTs regardless of whether they're three-phase or single-phase, because like I said previously, you can install a single-phase system onto a three-phase property. So although we have the three CTs, they're clearly numbered, 1, 2, 3. So for any single-phase installation, we're only going to worry about CT number 1, which is for single-phase. Plug the transducer, which comes with that little black connector, into the A1 port. Then we take CT number 1, open it up. They are directional, there's a little arrow, so the power flow always goes out towards the cable. That's the easiest way to understand it. As you can see, the little arrow there. And then what we're doing with this one is we're just going to grab it onto the AC going to all of the different loads. and we just tidy up the cables. Now, given that the PV is already going directly into the sonnen system, all we need to worry about on this installation is measuring the loads, measuring the consumption. AC comes in through the main isolator, then from there it goes out to all of the various different RCDs and out to the load circuits. So this is all the load circuits going out, and there we have it. Next alternative setup will be the consumption measurement. As a PV comes up, so this installation, you can see we've got the solar. Through the solar isolator, then the solar is in parallel to the grid supply. So we've got the grid supply, comes in here, the grid comes in, combined with the PV. We've then got a supply coming up from the output of the main isolator to all of the load circuits. So the load circuits here can be seen isolated to everything else. So the main difference is there are two setups. We have grid measurement and consumption measurement. The reason we have the two is that consumption measurement is purely looking at the power going to the loads. It's the most accurate form of measurement to look at the actual domestic consumption. The sonnen system will then calculate what's going on through the grid connection. The alternative, as per the previous video, is looking at grid measurement. That is looking at the power flow to and from the grid, and it's then calculating what's going on at the loads. In an ideal scenario, we'd always look at consumption measurement, because as I said, it's the most accurate. However, it can be tricky if the PV, any existing PV, has been wired onto a subboard or is embedded within the switchboard somewhere. This installation here is your sort of ideal scenario because the solar is coming straight off the bottom of the main isolator coming in from the grid. We can very, very easily separate out all of the supply going to the loads. Meter comes on. We get the meter wired up. And then what we will be doing in this installation is we're going to be having both sets of CTs, or two sets of CTs, one measuring the loads, the consumption, and one measuring the production. Okay, so the CT set, the transducer, what the transducer is basically doing is bringing all of that measurement value into one Modbus signal, which goes into the meter. As per before, we take CT number 1 and we just take that onto the supply coming out the main isolator, which is just going to the loads. So we've been able to separate out here just the load consumption itself. So all that power goes out through the MCBs, out to all the load circuits. So next configuration, again, it's the grid measurement, but grid measurement also taking into consideration any AC coupled PV. So once more, we get the AC connection from the sonnenBatterie system in, earth on and then neutral in. Then we take out MCB for the meter. So the reason we have that MCB is in some circumstances we will want to be able to isolate the meter to be able to restart it, or just to be able to turn it off. And our active supply from the MCB, which will be going to the meter, and neutral coming down. And once more, we take our CT set, transducer on, we take this one into the A1 terminal, which is looking at generation. And very simply, take this onto the AC supply coming out of the MCB, which is connected to the solar input. So we have solar in to the MCB, and transducer number 2 is going to be for our CTs measuring consumption. Consumption measurement configuration. Now here we have the solar coming through the solar MCB. And the solar then coming straight in to the grid supply, load side of the grid supply. So that's the grid coming in. To its main isolator. On the output side, we're coupling into the solar, and then all the supplies through the load circuits and out to the loads themselves. So once again, we get the AC isolator in place from the Sonnen system, and then we take the supply from the Sonnen, or the active going from the Sonnen MCB through to the combined AC from the main isolator. The meter goes in again. Now bring our CT sets in once more. So transducer goes on. First thing for generation. And generation, very simply, just goes straight onto that connection there, coming out from the AC isolator from the PV system, which connects through to the main MCB, or main grid supply isolator. And then we plug in the CT set, the transducer for consumption. Takes CT number 1. Then we take it onto the separated supply, which is just feeding the load circuits. So all the CT is looking at is the actual consumption itself. Now let's look at a slightly more unusual one, where we're going to be putting a single phase Sonnen system onto a 3-phase property. So here we have a 3-phase board. So we just wire the single phase Sonnen AC connections into that. Now obviously with a 3-phase board, you have the option of wiring the Sonnen system onto either L1, L2 or L3. Now for this example, we're just going to put it straight onto the L1 configuration. If, however, let's say you had a PV system on L2 and you had your Sonnen on L1 or L3, doesn't really matter, you'd still be able to allow for that production to be able to be utilized for charging if the production is greater than the load. All the Sonnen system is actually going to be doing is aggregating all the values. Now, given this is then obviously a 3-phase meter setup, we're going to need 3 isolators, 1 per each phase. Now this can be slightly confusing or slightly, I suppose, challenging at times, because it's a little bit of an interpretation within the standards whether or not the isolator for the Sonnen meter needs to be a latched 3-phase meter, or sorry, a latched 3-phase isolator. We actually need to be able to isolate out the phases separately to be able to test whether or not the meter has been set up correctly. So we need each of those MCBs to be unlatched so that we can switch off L1, L2, L3. Now the meter itself is not a three-phase load. It will happily operate on 1 or 2 or 3 phases, so it doesn't need to be a latched three-phase MCB. Okay, so neutral goes up. So obviously with three-phase insulation, we have an awful lot more connections to have to take care of. Now the meter, the sonnen meter in a three-phase scenario will, or when we're wiring into a three-phase scenario with the sonnen system, the meter itself will actually have to be reprogrammed. For that we need an LCD screen, and there's separate tech note to explain to you how to go about reprogram it. For this illustration, what we're actually taking is a three-phase meter. So this one has already been pre-programmed for three-phase configuration. As usual, we then connect up the Modbus connection, and there we have it. The meter is in place. All we now need to worry about is getting all of the CTs in place. So CT set number 1 going into A2, we're just going to be looking at consumption. So what we're measuring here is the power in and out of the main grid connection point. So purely grid measurement. It is important to make sure we obviously get the CTs on the right phases. That's why they are so clearly labelled. 1, 2 and 3. If you don't, it can be able to be identified, hence the reason why we need the 3 separate isolators, but unfortunately there's nothing we can do on the back end to reprogram it. It will be a case of having to revisit the site and put the CTs onto the correct phases if they have inadvertently been wired or been connected onto the wrong phase. So there we have CTs 1, 2 and 3, and we now put on our transducer set for the solar connection. Now for this installation, it's actually just got a single phase PV installed, so all we're going to do is we're going to take CT number 1 and connect that through. Now as this is a consumption measurement, the sonnen system knows it's a consumption, so it will take out the PV from the overall total. Now we're going to do a 3-phase configuration in a grid measurement. So this is going to be looking at power flow in and out of the grid. It's going to have the solar taken into consideration by the sonnen system. Now we're going to wire in the 3-phase switch. Again, unfortunately the 3-phase switch is not included with the bill of materials for the sonnen system, so you will need to supply that, and it does need to be a latched 3-phase isolator. And then we get in place earth and neutral. So now, just like as before, the meter needs to have 3 separate single-phase MCBs. It is not a 3-phase load. Each phase of the meter can be disconnected and activated and deactivated separately for testing purposes and for functional purposes, so it does not need to be a latched 3-phase MCB. If anything, putting on a latched 3-phase MCB for the meter will cause more problems. What is very important when connecting all of this up is to ensure that the phases are correct. So the phases for the metering, the phases for the CTs, and the phases for the sonnenBatterie, they all need to be consistent. Using color-coded cabling or the correct harmonized cabling is the simplest way to do this. Unfortunately, I have seen an awful lot of boards where everything active is red. So this, again, 3-phase meter, neutral, L1, L2, L3. Okay, done. And then once more, we connect our Modbus connection so that the meter can happily communicate with the sonnenBatterie system. Now we take our CT sets once more. First CT set we put into A1 because we're going to be measuring the generation for the existing solar, which is this MCB here. Again, ensuring you get the CT the right way around. Look at the arrow in the direction of travel, if you like, of the power, and that just simply goes onto the AC out of the MCB. Next one, we're then going to take our transducer, our CT set for all of the consumption measurements. Now, given this is a little bit more involved in this switchboard, what I'm doing here is actually wiring the CTs in reverse, going 3, 2, 1, just because it's a bit simpler more than anything, nothing special about it. Three, 2, and then 1. Next one, we're then going to look at, again, three-phase system with consumption measurement. So again, to reiterate, what do we mean by consumption measurement? Consumption measurement is purely looking at the power flow going to the loads. So the production, the solar, and consumption are measured separately. It's the most accurate form of the sonnen system, being able to measure the actual load. Everything, if you like, going in and out of the grid is then a calculation. Grid measurement is the opposite. We're measuring power flow in and out of the grid, taking into consideration the PV, if it's DC or AC coupled, and then we're calculating the loads, we're calculating the consumption. So it all depends really, at the end of the day, well, two things. One, what the customer would like. Is the power flow in and out of the grid the most important thing, or is it the power flow to the actual loads the most important thing? But also, it's actually to do with how simple it is to wire the installation. So if you've got a nice, new, neat switchboard, like I'm showing you here how to wire, it probably doesn't matter. You might as well do the consumption measurement. If, however, you have got a property with a whole series of different subboards, you may have more than one bank of boards coming off separate other boards. The PV may not necessarily even go into the main switchboard, it may go into a different subboard. What this means is that if you can then bring the sonnen system back to the main subboard or the main board, all you need to do is measure the grid connection, and it doesn't matter where everything else is integrated, even where the solar is integrated, as long as you can get your CT onto that solar supply, it'll measure, and the measurement of the sonnen system will then work out what the loads are. So all it actually then needs to look at is the grid. So it really is giving the installer options depending on how a property has been wired and what they're going to find when they rock up on site. It gives them the best of both worlds option on how to wire or position the CTs. It's not a fixed requirement. You can either go grid measurement or consumption measurement. Now, what I'm not showing in this video series is how to do multiple sonnen systems. There is a video on the sonnenAcademy explaining how to do multiple configurations of sonnen systems. If you're going to be looking at having multiples on the same property or the same switchboard, the only real way to do that is actually to do a consumption measurement configuration, so that you then end up having to run CTs between each of the sonnen systems. There's a little bit more tricky, but like I say, there is instructions on how to do that on the installation videos within the sonnenAcademy main site. So now all that description's over, you can see that the main isolator has been, the main sort of three-phase latched isolator for the sonnen system is in, as well as the three separate MCBs for the meter has now been nicely wired in. Neutral just going in. Now what you probably also notice with all these videos is that the meter doesn't require an earth. That's because it's a separated extra low voltage meter, so no earth required, just the neutral, L1, L2, L3 on a three-phase system, or just obviously a single active on the single phase. So once more, neutral goes in, L1, L2 and L3. And our CT set goes in, transducer, plug this one straight into A2. So now, as this is consumption measurement, we're having to separate out the AC just going to the load circuits. So as you can see, I'm not CTing the loads for the sonnen system, they are separate. It's purely the load coming out of the main isolator going to the load circuits. So not included within that is the power flow from the sonnen system or the PV. And lastly, CT number 3. So using this nice large switchboard, it's got, as you can see, quite full in there. So I'd expect that most installers will be going for the grid measurement setup because that's simpler. Our CT set here going in for our generation, plugging that one into the A1 terminal. Again, as this installation's only got single phase PV, we're only going to be using CT number 1. Consumption measurement on a 3-phase board.